Hey folks, we're gonna talk a little bit about integration in kinematics, and we've already talked about derivative, or if you haven't, hopefully you've seen a video on derivative in kinematics. But for integration, we're going to start with the following two definitions. We know that instantaneous velocity is the derivative of position, the rate of change of position, and acceleration instantaneous is the rate of change of velocity, both of these with respect to time. So let's say I give you the following function for acceleration. Let's say acceleration is equal to 6t minus 4t squared. Now that would be an unusual acceleration, but let's say you got that. Now leave a little space over here. There's two more things I'm going to have to give you shortly, but I want to wait until we actually need them. All right, so the first thing I like to do is figure out what's the velocity as a function of time if I have the acceleration, okay? So we're going to use this first relationship, and I'm going to rewrite that as dv equals a dt, okay? And I gave you a description for acceleration. I gave you the equation for acceleration, right? So we're going to plug that in. So dv equals, and I'll put a parenthesis around this, 6t minus 4t squared dt. Okay, let me make a little more room here for us. All right, so now we have to integrate both sides. So we're going to integrate this side and integrate this side. The left-hand side, for virtually all the integrals we're going to do in here, we're going to use definite integrals. So there'll be a starting and a final limit. So we're going to go from v0 to the v at some time later. And time will start at 0 and we'll go to time, okay? So for dv, you end up with a v, but evaluated from v0 to v. On the right side, we have to integrate. So we're going to use our polynomial rule. 6t becomes 6t squared over 2 minus, and then 4t squared becomes 4t cubed over 3. And we have to evaluate that from 0 to t. Well, that just becomes, just plug the t in, basically. So then we get, on the left side, we get v minus v0 when we evaluate that. On the right side, we do a little simplification. You get 3t squared minus 4/3 t cubed, and that's it. Now, to find velocity as a function of time, in other words, we're solving for v. Well, I need to give you v0. So somewhere in the problem, if I gave you this acceleration and said, hey, what's the velocity at 4 seconds, okay, you would need to know a v0. So let's say I tell you that, let's say a v0 is 5 meters per second, okay? So then I would put a 5 right there, and I'm going to move that over to the right side of the equation, and then you have now velocity as a function of time is equal to 3t squared minus 4/3 t cubed, and then the minus 5 over here becomes a plus 5. So that's your velocity as a function of time. Then you could find things like what's your velocity at 3 seconds. You could just plug in a 3 for time and get a velocity. You could also do things like if I asked you to say, what's the average acceleration between 1 and 4 seconds, okay? Well, average acceleration is change in velocity over time. So what you would have to do here is you would plug in 4 into your velocity equation here, get a velocity. So that would be the velocity at 4, okay? Minus, you would have to plug a 1 in for time there, and that would be your velocity at 1. And then you would divide that by how much time elapsed, which is 3 seconds, and that would give you the average acceleration over those 3 seconds, okay? Finally, if we want position as a function of time, well, now we're going to use this equation, all right? So we're going to solve that for dx. So dx is equal to v dt, okay? So dx is equal to Put the velocity in parentheses. 3t squared minus 4/3 t cubed plus 5 dt. Okay. Now we have to integrate both sides of that. I need limits. Delta x will go from, or dx, x will go from some starting position to position at whatever time you want. Time again will go 0 to t. The left side, when we integrate dx, we get x, but we have to evaluate that from x naught to x final. On the right side, we're going to integrate all this crazy stuff. You get 3t cubed over 3 minus 4/3 t to the 4th over 4 plus 5t. And we have to evaluate that from 0 to t. Well, again, when you plug in 0, you're just going to get 0, so I'm not going to worry about that part of it. Okay, make just a tad more room here. There we go. Okay, and on the left side, we get x minus x naught, okay, equals. I'll simplify this a little bit. You get 1t cubed. Now, do you have to put the 1 there? No, but I like to put it there just to remind me it's there. Here we get a little bit of canceling. You get 1/3 t to the 4th plus 5t. So what else do I need to give you if I want x as a function of time? Well, I need to give you x naught. So in this problem, I would have also had to give you x naught, which let's make it 20. So again, that would be given in the problem somewhere. Otherwise, you couldn't do this problem. Okay. So then you say x naught is equal to 20. You move it over to the right side. You get x as a function of time is equal to 1t cubed minus 1/3 t to the 4th plus 5t. Then that would become plus 20. Okay, so that would be your position as a function of time. And just like in the derivative video, we could then find, like, hey, what's the average velocity between 1 and 4 seconds? Okay, well, you would need the velocity at 4 seconds minus the velocity at 1 second over the time elapsed. So, I'm sorry, I messed up. This would be position at 4 and position at 1. Oh, my goodness. All right, position at 4 seconds minus the position at 1 second over t. So you would plug in 4 seconds for time here and here and here, get a number, that would go here. You would plug in 1 second for time in those time places, that would put you a number here. And then your elapsed time at the bottom would be 3 seconds. 1 to 4 is 3 seconds. And that would give you an average velocity for that 3-second span. Okay. A couple other notes here, depending on what you're trying to do. If they didn't give you, so let's say they asked you the following question. Let's say they didn't give you x naught. Okay, let's say they didn't give you this. But let's say they did ask you, how far did the car go between 1 and 4 seconds? Okay, how far did the car go between 1 and 4 seconds? Okay, well, what you could do is this is what we call delta x. That's how far the car goes between and for any amount of time. So if I said, hey, how far does the car go in 4 seconds? You could plug in 4 here, here, and here, and then you can plug in 1 there, there, and there. If you want to know the how far the car goes between 1 and 4 seconds, you plug in 4 seconds, get an x. You plug in 1 second, get an x for that, subtract them. Okay, so that would give you a delta x. That would be how far the car went. In that case, you wouldn't need the x naught because it's going to be in both sides. And so you'd end up with a 20 and then minus a 20 later on, and it would cancel out. Okay. All right, so that's how you integrate to find, given acceleration, how to find velocity, and given velocity, how to find position as a function of time. I hope that was helpful, and thank you very much.